All right, yeah, welcome back. So now we want to look at canonical variate analysis. Canonical variate analysis is a method used to find the shape features that best distinguish among multiple groups of specimen. Okay, a group membership is assumed to be known as a priori, and it's actually analogous to some way in some ways to discriminant function we just finished now and maneuver, because it looks at the variate among groups in a coordinate system that is modified so that within groups variation is isotropic. All right. So the corresponding computations involve the inverse of the within group covariant mix matrix, or especially in the context of geometric morphometrics, a generalized inverse of the within group inverse matrix. All right. So it's a very common method used in morphometrics. So it also gives us actually give us the shape, the uniform, the general shape, and also the chart. So when you are having more than two groups, okay, you can introduce most times, though you can introduce covariates, canonical variate analysis to help you out. In fact, it separates the group better, much more better. So you can see the group being separated. It has this internal function that helps you to separate your groups in a better way. All right. In a, I mean, the scatter plot is perfect. What I mean in this particular method is perfect. So if your group is if your group is not well separated, when it comes to CVA, canonical variant analysis in MorphoJ, it helps you to regroup them. It has internal function to do that in a special way that you form a good scatter plot. So let's see how to do this in MorphoJ. So we are going to go back to our, so we are going to be using this one because this one has more than two groups. We have age and the rest there. So let's select this and let's go to our comparison as well. Click on canonical variate analysis. So we can give it a name dash 1. So let's say you have already you have chosen our age. So we are using let's say age here, so because it also have a sex. So we are not using that. We're using the age. So you can pairwise it if you want. All right. Making it a 10,000 coverage. So it will take some time. So let me just use 1,000. All right, to make it faster. So let's execute now. If I click on execute here now, okay, to run. So it's still loading now. So it takes some time. I just wait for a while and let it compute. That's why I reduce it to 1,000 so that I can do faster. But it has given you the shape. So the shape. So you are just waiting for this uniform shape for the three groups. All right. We have adolescents, we have adults, and we have young adults. Okay. These are the three groups. So, but this is a mean shape. Okay, that's finished. This is a mean shape for the three groups, right? So you can see this score here. See the score? Can you see the score? It helps you to separate them, so you can just or increase inside the point. Let's say we make it 8 points. All right, so let's use 8 points. You can increase the point more than that. All right, so if you don't want the color, you can change the color. You know how to do that. I've told you how to do that, so you don't need to bother. So just change the color to color you want. All right. So this guy. So don't forget the method I taught you also in Paint. So when you save it, you can crop this and drag it and drop it either here or here. Okay, so that you can crop out all this external space out, so that you don't leave any space outside. All right. So that's the method. So now this is what you are doing. So we have gotten it. Let's go and look at the result now. Result. This is our shape. This is our score. All right. So this result is a little bit different from the one we just saw in the signal function. Now look at it here. Let's go down a little bit. So here, from here, we have the result here. CVA here 1. So data set, we use age. The groups are ado, and yard. Don't forget, ado means adolescence, ado means adult, yard means young adult. So give us observation for each observation is giving us here 41, 26, 36. So this means observation, this means groups. All right. So ratio among groups is giving us the eigenvalues and their variance and cumulative results. So this is a global test against the null hypothesis of no difference among groups mean. So permutation we did is 1000, so that's why it was faster. So good that good Hall F result give us 1.1 and p-value is 0.3, not significant, and also Pillar's trace also give us a result and the p-value 0.1 also not significant. All right, so when you scroll down, you can see the other result here. So this one is for this one is for this. So giving us the intersection result there, and then these are the p-value, also the p-value for them also here. All right, so you can scroll down also to see the rest of the result. For Procus distances, this is the result and this is the p-value. All right, so you can see between this and the, if you, this one is here, this one is for this. So you can see the intersection of each of them. So which means Adu against Hado, Yard against Adu, Yard against Ado, and also Yard against Adu. So that is for both the solve, I mean the Procus distance and the p-value, the same thing. So p-value here is none of them is none of them is significant here. Also here, none of them is significant here. So you can see this. So you can scroll down to see this CVA score. Okay, this is CVA score. This is CV1, CV2. So you can copy this CV out also and use it to compute in other environments. We don't want to maybe to see to test further. So this CV1, CV2, you can see it here. CV1, CV2. Okay, you can copy it out. I mean, copy the result out. This is what he gave us. You can copy it out and we compute somewhere else the result. All right, so this is how to do the computation of the CVA, canonical variate analysis, and the so this one you can just export this out now and use it for your result. You can see it's more let me say make it 10 more bigger. So so you can just export it out. So that's that for now today. I will see you in the next class. Thank you so much.